Okay, shall we continue? All right. The next topic we are going to consider is rotating. Okay, this is rotation of a matrix. Rotating one function we have, it is called as ROT 90. It's used to rotate a matrix counterclockwise by 90 degrees, right? So this is used to rotate, or it rotates a given matrix counterclockwise by 90 degrees. This is first option. Let's do this first, and then I'll show you the a slight variation in this. So first, let's create a matrix, and A is equal to, let's say this is 1, 2, 4, right? So let's create this matrix. Now I call matrix B is equal to, this is ROT 90 of say A. Matrix A is getting rotated by 90 degrees in counterclockwise direction. So, right, whatever moves, something moves up, something will move to left, then something moves to from leftmost corner to down, right, and down from the downmost downwards location to the right position. So you can see that 2 comes to the position of 1, 1 goes to the position of 3. It's actually rotating, correct, counterclockwise. Okay, now there is a variety in this, right? That is, I want to rotate a particular matrix, say 3 times. Let's assume if I rotate B 3 times 90 degrees, 90, 90, 90, it's 370. Already there is a 90 rotation given to B. And if I rotate B like that 3 times, I should get A back, correct? So let's do that. So C is equal to, what if you want to provide the rotation simultaneously? Okay, so if your intention is to provide this rotation simultaneously for 3 times, I don't want to call rotate 90, rotate 90, 90, etc. I just want to call it in a single stretch, want to have a rotation 3 times. Okay, so then ROT 90 itself is a function, but you can specify, say B, do it 3 times. Now B already has got a 90-degree rotation in it. When I rotate B further by 3 times, it's actually ultimately giving 490 degrees, which is 360. I should get back A as answer. You see, C is equal to, C and A are same now. It's ultimately you rotated A 4 times, 90, 90, 90, 90, 360. So you have this answer over there. Okay, so that's the concept of rotation. Again, we can rotate this in the following order. Okay, then the next very important operation in matrix is the sorting of a matrix, right? Again, you don't have to write a variety of programs to do a sort. A single command is going to perform the sorting operation for us in MATLAB. Okay, so this is, okay, I have not written the function here, so I'll write the function used ROT 90. Right, that was a previous function. Now we'll go on to the next topic. This is the sorting. So sorting the data in an array, right, is actually a very useful tool, right? MATLAB provides you a lot of options to do this, right? So we use a function called sort. Okay, is a function. By default, this sort function sorts the element of each row or column, right, in ascending or descending order. Okay, so this particular function, right, you can apply them to sort the rows or matrix, rows or columns, and again you can perform the sorting in ascending or descending. These are the options we have. Now let's look at the application MATLAB window. Okay, so let's create the matrix first. Say create matrix A is equal to, for say 5. Okay, it creates a 5 into 5 matrix as of now. So simply I call the sort function to see what happens. Okay, so B is equal to SORT of A, right? So you see here, right, column wise your matrix got sorted. First column it's going to consider and it's going to arrange it in the ascending order. Every column is in its own ascending order. Finds out what is the minimum number in that column, replaces that to the, it moves that to the first position of that column. Then the second one will be second largest number of that column, and so on. This is repeated for each and every column that is present in the matrix. So when I simply call the sort, right, it's going to sort each column of that matrix A in this particular case. Okay, now what if I want to sort each row in the descending order? Okay, let's say so for sorting rows in descending order, I still use the function sort, but the details I am supposed to enter into that function are slightly different now. Okay, so let me show you that now. So I'm going to call, I'm going to write like this. So I'll create a new matrix, say matrix C, okay, is equal to, this is sort. Okay, I'll tell which matrix. It's definitely matrix A, and I'm going to tell you, right, what I want, right, because if you want to tell MATLAB that I want to deal with the rows now, not columns, because default is columns. When you want to say it is row, I have to write the second argument as 2, because 2 for rows, 1 for columns. Okay, 1 is by default, it's this. Then you specify how do you want to go ahead. Are you preferring to perform ascending order or descending? You can write the text here in the single quote DE. I just have to enter descend. Okay, DESCEND. Close this and close. Now you see, enter, right? So row wise, every row of matrix A has been considered here. Okay, I'll just write A here, type A here just for comparison. So see, you're considering the first row and descending order. First element will be the biggest one, so 24, then 17, right, then 15, then 8, and then 1. That is actually coming from this, the first row of A, right? Every row has been done. Now if you change this with A comma 1 comma descend, it's going to perform, right, the column wise descending order. Okay, so like that, right, it's going to perform. So we know all the options now. What are the options we have? We can write 1 or 2 here, right, in this position, just to specify whether I want to go with the row or column. Okay, and in this in the third argument, instead of descend, if you write ascend, that's going to perform the ascending order of the selected 1 or 2. 1 for column, 2 for row. Okay, so that's the sorting options available. All right, then now let's go to the specific case of multidimensional arrays. So we have considered, we have seen a 3D, right, as an example previously, but now I want to consider whether it is possible to create even a multiple dimensions, right, fourth dimension, and so on. Is it possible? We'll see. Okay, so the first one is, let's look at the is it possible in a very simple fashion, what exactly is a multidimensional array? We will consider. Okay, we'll see that first, and then we'll extend the concept further. Okay, now, so let me paste this. So you can see that the multiple dimensions or multi-dimensional arrays is the one which has more dimensions than more than two, right? If the dimensions that you are going to consider is more than two, then we call such arrays as multi-dimensions array. So, right, you try to extend a two dimension to the third dimension, it becomes a 3D array. So you can see here, right, on the right side, you can see there are several pages written. So first element is, right, is a row. You first dimension is row, second dimension is column, right? So rows and columns will fill your page. Okay, first page is over, right? Then what we do, we go for a second page, right? So always you see that if I have only one page, it is a two-dimensional thing. Okay, but then I extend this further, saying that once first page is filled, you go to the second page. Then you will have to specify second row, second page, third row, fourth column. You see, you are actually adding a new dimension to that. That's what is happening here. Once this page is filled, you go to the next page. So you increment the page number. So second page, once again, first row, first column, first row, second column, and so on. Then once that page is filled, you go to the next page, and so on. So you see, this is a three-dimensional array, right? Matrix has been extended to C. So the index, first two indices are going to repeat. You see 1 comma 1, 1 comma 1, 1 comma 1. But what changes here? What changes is the third subscript, right? That is 3 for all the elements in the third page. It is 2 for every element here, 2. Here you can see 3. And in the first one, you can see this is 1 for every element over there. Are you okay? So that's how we are going to consider or create a three-dimensional matrix, or further extension of that will give you a multi-dimensional thing. All right. So let's see how to how to create a two-dimension, and how to extend this further and create a third dimension, and so on. Right. So let's go back to the MATLAB window to understand that concept. So let's first create a 2D thing. Okay, so let me create A. So matrix A is equal to, let us create a 2 rows, 3 columns. Okay, or maybe, okay, let me create a 3 cross 3 itself. That's easy for us. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the first. First, let's assume that we created a two-dimensional array. Okay, it's a matrix. Now I want to add a page to this, right? I want to extend this in the third dimension. Whatever elements I'm going to enter now, I don't want that to be present in this page, but I want them to go to the next page. Okay, so how to enter that? Actually, that is pretty straightforward. You just say that the page number is 2. Rows and columns will remain same, but the page number is 2 for that. That's what you are supposed to tell now. So in matrix A, all the rows, all the columns, but second page, right, should be equal to. Now you see you will enter one more set of matrix here, but the size of the number of elements you enter here should match the size of your already existing A, that is 3 rows 3 columns. I should enter like 11, 12, 13. Then I should go to the next row itself. Okay, 16, 17, 18, 19. So close this. Now you see it actually displays A in 2 pages, right? See, the first page is A, all rows, all columns of first page is nothing but your previously existing A. But recently added 11 to 19, they came to this, we instructed machine that put it in the second page. So you see it is actually in the second page. Like this, you can definitely add a third page, fourth page, and so on, right? As you require, you can keep extending this. Okay, this is how you create a 2D and then extend this to the multiple dimension. Okay, then I have another very useful function called cat. Okay, this is used to build a multi-dimensional array, right? You can create a like I can actually specify, right? I can, if I have a matrix with me, I can actually specify which dimension I want to perform the concatenation. It's a cat function, cat for concatenation, it's a short form for concatenation, and we can use that as well. Okay, so let me write that first, and then we'll come back to the MATLAB window. Okay, so we can use this is called as a function called cat, right? This is used to create a 3D array of, say, some matrix. Any matrix you have, you can extend that further to create a new value. Okay, right. So this is function cat. This is used to create multi-dimensional arrays. So for example, let me write something like, okay, let me go back to MATLAB, and there itself I will show you. So this is what I'm going to do now. I have matrix A itself with me. I'm going to extend this to create a B now. So B is equal to, I'll call cat. Cat stands for, in this case, it is a concatenation. Okay, you have to specify which direction you want to add. Let me say I want to keep the size of each array same, like 3 cross 3, but I want to add it in the third dimension. So you have to specify the dimension first. Third dimension. In the third dimension of matrix A, right? Then specify what are the elements you want to add in the same order. Like maybe now I'll enter in random, say 21, 22, 23, then 31, 32, 33, and 42, 43. Okay, so this actually I entered another matrix of the same size as that of every page of A, correct? Just you know, so the B is nothing but in B the first 2 pages are same like A, because everything is in A, but A plus something, A plus these numbers. So the last page actually contains the newly entered elements. So this is What is the usage of the function called cat? Okay, just remember the 3 I mentioned is for the third dimension, right? We know that 1 for column, 2 for rows, 3 represents the third dimension. That's in our XYZ coordinate, it is a Z coordinate. Okay, first dimension, first argument in this particular whatever command we write, right? That has to be the dimension in which you want to perform the concatenation. Okay, that's how it is. Then let me show you another quick way, right? I want to convert this B into a multi-dimensional case, but I want to keep all values of in that new dimension to be 0. This is possible, right? If you remember, we had done a similar job for a 2-dimensional case, but now it should become clear to you that even whatever we did for 2-dimensional cases can be extended to the 3 dimensions as well. Okay, multiple dimensions. So for example, you see here, I will create a 4th page, but all zeros. Very easy, right? B of, right, all rows, all columns, and the 4th page, right? Simply make it equal to 0. Let's see what happens, right? So B actually got extended, right? First 3 pages are same. It simply created a 4th page and initialized all the values to be 0. This is the quickest way to extend, right? You can put these values in the program. I just understood that, okay, this particular variable is going to be a 4th dimension. So 3rd dimension or 4th dimension, any new dimension has to be added, or new page has to be added, right? You can simply create that by doing this, and later on, right, when the values come up, you can put it over, right? This is the quickest way of doing this. Okay, this is the expansion. Then we can definitely access a multidimensional array. So I'll show you the accessing of a multidimensional array as well, right? So it's the same concept, so I don't want to write over there. I'll quickly show you how to go ahead with this. Okay, so let us say I want to read first and the second element, or first row second element in the second page of A, let's assume, right? How to do that? So A I'll write first. I want to read the first row second element, right, of the first page of A. So how to write that? This is A of, it's x comma y comma z, first row second column first page. So what you are going to read, first row second column is 2, right? So you see you are getting it 2 there. What if I want to read the second row third column of the second page, right? So to do the same thing, A of second row third column second page. See 16. So in the second page, this is the second page of A, right? Second row third column is 16, right? So you see you are reading this. This is how you access element by element, first element, second element, and so on, right? Every element you want to read, you can do that. Then we saw how to read the complete row or complete column of a page, right? However you do it in the regular matrix, you can do that, but specify even the third dimension now, because which page also should be important, correct? Let's do that. So I want to read the second row of first page. How do you do that? A of, it's a second row, says second row specifies all the columns, correct? Second row, all the columns of, I have to specify which page. If it is first page, enter 1 here. Okay, first one. If you want to go for the second one, do this. If you want to read both, can you do this? Yes. Read the second row of both the pages, right? Second row, all columns, all pages. You can do that, right? Right? So specify colon operator over there for the column number as well as the page number. Okay, like this. Now, this is how you read the specific this thing. Well, again, I can read the complete pages as well, right? So maybe a of, I want to read the complete pages, like complete second page, right? Complete second page indicate that all rows, all columns of second page. That's all, right? So you see, you read the entire this thing, right? Whatever we have used in a simple two-dimensional case can be extended to third dimension, fourth dimension, and so on, right? So element by element you can. Now, how do you read the first and the third column, right? I want to read first and third column all together. You can do that. So of matrix A. So A, matrix A, all rows, but I want to read first and the third. Oh, sorry, it's not 1, 3, it's 1 space 3. It's a vector, right? Do you remember we did this? Comma, specify the, if all pages, right? So just see. In the first page, the meaning is this: in the page number 1, first column and the third column; in the page number 2, first column and the third column, like that, right? When you have multiple, let's go to B, right, and specify certain more things, right? So B is actually, right, B has 4 different pages, so this becomes more clear to you. So if I say in B, right, uh, I want to read specific columns from specific pages, right? I want to read specific columns like first and the third column. So I'll say vector 1 space 3, first and the third column. Again, I don't want to read the first and third columns of all pages. I want to read only from the second and the fourth page. So still you can specify that 2 space 4. Just see. Okay, so the column numbers are 1 and 3 and the page numbers are 2 and 4 in the second page. So you see, this was the second page. In the second page you are reading that. Okay, and second and fourth page. Okay, second page is the 1 and the fourth page is all zeros. So you can see that yes, it's reading in the required format. Whatever you specify, you can get it from this. Okay, using a single command, right, by using column operator and the vector form, right? You can read element by element, you can read a specific row and column from any specific page, sets of rows or columns from a specific page, or the whole page of any specific number. All right, now, so since we are in a multi-dimensional case, let's finish off with reshaping and rearranging the elements of a multi-dimensional array as well. Okay, that is also pretty much important. Okay, so the next topic that we are going to consider now is actually the reshaping of multi-dimensional array. So again, the function used is reshape. This itself is the function. Okay, now okay, let's create an array first and then we'll come back. Okay, so let's see. Anyway, since we know the usage of a reshape function, I can directly show you in MATLAB itself. So let me create a matrix first. So let's say A is equal to, should use this 1, 2, 3, 4, 5, 4, 5. Okay, so I created matrix A now. I want to extend this to a two-dimension case. So how do you do that? This is A of all rows and columns of second page. All right, this has to be equal to, just enter new values. Okay, extend this by using, maybe I'll use this a new set of values. Okay, this is 1, 2, 3, 4, 5, 6, 10, 14, 15. Okay, we added 15 more values. Okay, so now A is a two-dimensional case. Okay, sorry, three-dimensional array. Okay, now I want to rearrange this, right, in a specific way. So you count the number of elements I have. So what's the total elements? So 15 plus 15, 30 I have. I can reshape it into any format which ultimately counts for all the 30 elements, right? So let's do this. Let me convert this into a two-dimension first to show how this can be done. So P is equal to reshape what? Reshape the elements of matrix A, specify what is the order, right? 6 rows, 5 columns, right? Will it take care of 30 elements? Yes, 6 rows, 5 columns means 30 elements. You see, B is in the same way, but just check how they are, how the values are read from matrix A. So you can see the first it is going to read 1, 11, 12 of the first page, first column. Then you see it is going, it's not going to the second column first, second page first column. It is going to finish the first page completely. Then it is going to come back. All right. So just see, it's initially it read from the first column of the first page. Then it moves on to the second column of that first page. 2, 22, 23 are filled to make the requirement as all the 6 rows of the first column of my result. Then it moves on to the third and the fourth columns of first page of A to create the second column over here, right? So 3, 33, 34, 4, 44, 45 have been replaced. 2 have been moved to P. Then now you can see it will move further. It finishes the last column, and since first page is over, it will move to the second page. Then it is going to read the first column, right? So 5, 55, 56, then 13, 23, 90, right, are present on the third column of our B. Okay, and so on. So like that, you converted that into this. Okay, all right, let's move on further. There is another option, right? I have another option. Another a variety of a function is possible here, that is called as a permutation. Using the matrix, we can apply permutations in MATLAB. So this is permutation, right? This is used to rearrange the order of dimensions of an array. Okay, let us assume that I think we already have the matrix with us, so I don't want to create once again. I'll just call it A. A is a a three-dimensional matrix. All right. Now, let me write the function that we are going to use. So we use the function is, it's called as permute. Okay, P-E-M-U-T-E. Permute is a function. Right. Now I have to interchange the rows, but keep the pages same. Okay. In case of say like this. Just show you the MATLAB window first. So I have matrix A with me. So let me use the same matrix. In this, I want to exchange, right? I want to do the permutation of the rows and columns, but I don't want to touch the what you call the page. So you see the permutation I'm going to perform now. So matrix say C is equal to permute matrix A, specify what you want to do, right? In the sense, here I'm going to create a vector, and that vector will tell you 1 for row, 2 for column, 3 for the third dimension, okay, the page. So what I'm going to tell, whatever you mention first becomes the row. In the sense, column should become a row, right? Row should go to the position of column. 1 goes there. Normally it is 1, 2, 3. Okay, 1 for a row, 2 for column, 3 for this. Now when I say 2, 1, 2 becomes 2 occupies 1's position, 1 occupies 2's position. All right, and 3 is kept at the same position. In the sense, I'm saying do not touch, right, the third dimension. Okay, so it's actually I'm taking a transpose basically, but for every dimension of that matrix, right? Just check now what happens. See here. So it was see a in a, it was 1 2 3 4 5 like this, right? You can see that it simply exchanged rows and columns of every page has not been touched. All right, now I'll show you what happens when you do with the when you deal with the uh, I'll keep 1 as it is. The second element is 3 and third element is 2. It means the page will be that of how many columns you had in A, right? A actually had 5 columns, correct? A had 5 columns, and how many pages A had? A had 2 pages. Now the result will have 5 pages, and in each page you have 2 columns. This is what is the result. You see, right? I can compare this with definitely A just to understand what happened. So you see in A, the first element you got, the first page in C is nothing but number of the rows are not touched. Okay, rows are as it is. You see first one and the second one, 1 and 13 came because it's the first row is still first row, right? See, first row elements are still first row, but what you wanted to exchange, you want to exchange the columns with the pages, right? So first column and the same first column, first row, first column, second page will be shuffled, right? So that's why 1 and 13 came into picture. Same thing happened. 11 and 23, you can go to and check this. 11 from this, 23 from this is the second one, right? So your next entry was 11 comma 23. Then the last one was 12, third row, and the third row from the second page. Like this you filled. That's why you got 5 such, because how many columns you had? You have 5 columns, right? So 5 columns will be converted into 5 pages now. That's why you have C pages, page number you count. It's 5. Rows are still same. All right, so try this, try varieties of options over here by yourself by changing write these numbers. Okay, whichever number you write first will be considered for rows, whichever number comes next for columns, then whatever comes here will be for the page number. All right, so that is the use of what is called as a permutation operation.